So as we have already communicated about this session, so Gaurav will be taking this session around, and we have tried to create a small solution considering circuit breaker design pattern. So you guys already know what circuit breaker is. So Gaurav will be taking care of the technical thing. I just want to set platform for this. So the circuit breaker, what it actually do? The electrical circuit, whatever we think, it's same. If a service 1 is calling service 2 and service 2 is not responding, maybe due to any reason, let's say there is a network failure or something like that, so circuit breaker will open the circuit. So your request will not override the network because service 2 is not available right that moment. So how to implement that? So that part will be covered by Gaurav. So I will not take much time handing over the mic to Gaurav.
Hello everyone. So very good evening to one and all. I guess there are some new people here as well, so I'd like to introduce myself first. So I'm Gaurav Agarwal. I am here at Credgenics from last 2.3 years almost, and I look after the voice module, feed or sheet module. So let's start with our topic today, circuit breaker design pattern, and feel free to interrupt me and ask any questions if you have any doubts. So let's start with it. So a circuit breaker design pattern is a very popularly used pattern which can be used where any two services are communicating with one another. Now these two services can be microservices or they can be one service which is communicating to a resource like a database. So at all such spaces we can use our circuit breaker design pattern. Before jumping into what exactly circuit breaker is, let's see what problems are we trying to solve here. So let's look at this diagram. So here there are four services A, B, C and D. These services are in a way dependent on each other for some data or some other request. And say in one case a D service fails. This failure can be a partial failure or a complete service might get unavailable. In that case, what happens is C, which is trying to contact D, will keep on waiting for the response from D, but it will not get any response since D is unavailable. Similarly, more and more threads of C will keep on engaging and waiting for D, but it will not get any response. More threads waiting for D will make less number of threads available to serve any request that is coming on C. Say, like here, B is trying to contact C, but slowly as the threads are busy waiting for the response from D, B is also not getting any response from C. Similarly, this chain goes on and a failure of one service makes every service which is dependent on it fail. This is popularly known as cascading failures. So this is one problem. Let's see another problem. Now I would like to explain you better with a story. Now as we all know that after the release we give DevOps some or the other query to run. So one release day what happened is after the release DevOps ran some query given by some person and that query ran forever. Slowly it started choking the database. Now since the release happened, our very dedicated FOS team started testing the new features that were released. But since every feature will try to connect to a database and since it was slow, it was not getting any response. So the service or the feature that was trying to call database could not connect to it, could not get any response, and slowly it started failing. What happened next was this. Alerts came one after the other. One alert came, second alert came, and the next day this message came. So this is actually a problem. Now let's see how circuit breaker will help tackle this problem. Now consider circuit breaker as a simple electrical circuit breaker or a switch. When the switch is on, that is when the circuit is closed, the current flows easily from power to destination. When the circuit is open, the current does not flow. Similarly, a circuit breaker does not allow request to flow when the circuit is open. The request flows properly when the circuit is closed. Now look at the solution to the problem which we saw in the beginning. Say for example, if there was a circuit breaker that was placed on top of D by C. So after a particular number of requests, a threshold has reached. After that, the circuit breaker will open the circuit. Circuit breaker will trip and it will open the circuit between C and D. Due to this, C will not be allowed to make any request from D because D is unavailable. Now what it is doing is it is giving D some time to recover, and at the same time the C is not having threads which are blocked for response from D. Due to this, C is healthy, D is able to get responses from C, and the chain continues. So in this way, failure in one part of our system is not affecting the entire system. So this is what circuit breaker is doing. Now I would like to highlight one thing here. Circuit breaker does not prevent the original failure which must have happened at D. It is just allowing our service to handle the failures more gracefully and to detect them early. Now, there are few states in circuit breaker. Let's go one by one. The first state is a closed state. In closed state, all the requests from one service to another service can be flown easily without any interruption. Now, let's say, before moving forward, I would like to highlight there are three main params here. There is a total request count which we maintain to keep track of how many requests are coming for a particular time. There is a failure count which maintains how many requests are failing, and then there is a failure threshold. This threshold, when the failure count reaches failure threshold, our circuit will be open. Let's look at this flow chart. I think it would not be very visible at the end, but when a request comes and the circuit is closed, if the request is success, that is the underlying service or resource gave a response clearly. In that case, we just increase our total request count and the response is returned. On the other hand, if the request is failed, then we increase the total request count, but we also increase the failure count. Now we check if this failure count is less than the failure threshold that we have set for that request. If the failure count is less than the failure threshold, we allow the response from the underlying service, the failure response, to go back to the user. But if this failure threshold has been reached, like failure threshold say was 10 requests and our failure count reached 10 or 11, then in that case the circuit will be turned into open state. Now what happens in open states? Let's see. Are there any questions now on this? Now what is happening in open state? So before going on to it, let's understand there are two things here. There is an open circuit timer. So whenever a circuit is in open state, there is a timer that starts which keeps on running. Until this timer is running, the circuit will remain in open state. So let's see, when the circuit was open, a request came. This request will be checked, like if the circuit timer is still running. In that case, the request will not be allowed to flow to the underlying resource or service, and the open circuit exception would be raised. This exception can be any of our custom exceptions that we write, and the request will not be allowed. This timer, please, you can see that this timer, until the time this timer is running, it is giving the underlying service some time to recover. Say, like there was a mistake from the developer end, or there was some other choking that happened. So till the time this timer is running, our underlying service is getting time to recover from it. Now when this open circuit timer is timed out, the circuit is set into half open state. Now this is the extremely most interesting part in circuit breaker. Let's see what happens in half open state. Now this half open state, as you can see, like in this state the circuit is neither completely open nor closed. The requests are allowed to pass, but there is a catch here. Say for example, there is a request which came. When the circuit is half open, the requests are allowed to be flowed. If the request is failed, the circuit immediately trips into the open state again and the timer restarts. So the circuit is set to open state again as soon as the request fails in an half open state. If the request is a success, then there is a success counter that we maintain, which we keep on increasing. Like in the open state, like in the closed state, we were using a failure count. Here we are using a success counter to keep track of the success counts. Similarly, in the open state, in the closed state, as we had the failure threshold, here we have the success threshold. If the success counter has reached our success threshold, the circuit is again set to the closed state and the system is healthy and it starts flowing the way it was flowing again. If the success counter is less than threshold, we keep the circuit in half open state. Hello. We keep the circuit in half open state until the circuit either goes back to open state or the closed state. So these are the three main states of a circuit breaker. Again, any questions? So let's again look at the advantages what circuit breaker is offering us. First of all, it is providing stability to our system. It provides stability as in it does not, it gives time for a failed service to recover. At the same time, any service does not repeatedly calls and waste its resources. It decreases the response time when there is a failed service. In the initial cascading failures example, we saw that C service was waiting for the response from D. When D service was unavailable, there was no chance of getting any response. So in that case, after waiting for some amount of time, after getting timed out only, then we are able to know that there is a failure. But when in this case, when the circuit is open, there is a quickly response which came back that the circuit is open and you cannot make any request. Now, circuit breaker states can be used for monitoring as well. It will help us see if our system is healthy or not. Whenever a circuit breaker changes the state, say from closed to open to half open, this can be used to monitor how our services are behaving. And finally, it can be used for alerting. Whenever a circuit breaker goes into open state, we can raise an alert to identify that a service is not working properly. So these are the advantages of a circuit breaker. Let's look at the Python support for circuit breaker. Now there are various popular libraries that we have in Python for circuit breaker. PyBreaker being the most popular one, but there is a catch that PyBreaker and circuit breaker libraries do not offer AC support directly to us. And since our system architecture requires asynchronous support, there are other libraries available like Agarwal and Leisure. Considering the popularity of the library, we are using Leisure. We are building on top of it. We are making some modifications and using Leisure. So yeah, we will not call it Leisure. We call it series circuit breaker because we have modified it as per our own use case. This library requires a state storage where we will be storing our state like Redis. So we have modified this library to work with our CG Redis library. And there are some other states also which we have, not states, there are some other functionalities also which we have included in this library. Yes.
So, like in the previous slide, so there is a response time which says there is a line that's likely to be failed. So how do I identify that it's likely to be failed?
So when the circuit breaker is open, you know that this the underlying service is failed and there would not be any response.
First, I have to wait for one request.
Yeah, initially once the failure threshold is reached, then only you will be able to identify. That threshold is under your control how you can set the threshold. But you cannot open the circuit on failure of one request. You should. Yeah, so we just have a demo and I'll show you what kind of failures you can handle here. Any other questions?
Yeah, what happened with Redis fails?
Sorry?
What happened with Redis fails?
What happens in Redis?
Redis fails.
When Redis fails?
Redis went down.
When Redis went down, then there would be trouble. Because all these counters which we just saw, like failure counter and success counter, or the state of the circuit breaker, we are storing everything in Redis only. So if Redis goes down, then there would be an issue.
So two things here. Like first thing is that we should have a fallback mechanism for a Redis as well. Well, a Redis as a distributed cluster should be able to handle a by himself. There is a replica of the cache which is getting copied and will be able to make him up. The second is, as a good suggestion, you should also incorporate the fallback mechanism. If say my storage is going down, then the flow should not stop. Let it count as a like everything is going fine as usual behavior.
Yeah, it gives the single point failure.
Sorry.
It gives the single point failure for all services.
Yes.
So basically, the first thing that we should have a then my Redis cluster should have a replica set always. Like if my master is getting down, then my slave or what read replica is able to pose himself as a leader. That is one thing. The second thing is it's a cluster. Redis itself is also a cluster. And it's not getting a bottleneck. So every key will have a replica as well. Correct. That's one thing. And his library should also support it. If it is getting down, then it should stop working and let the service communication happen like it used to be.
Service communication will keep on happening, but in that case, a problem that we are trying to solve here would be persisting because you will be trying to communicate to a service which is not available. Otherwise, you are communicating.
Not necessary. Maybe the service is available. Down.
Yeah, if the service is available, the request will flow. If the service is not available, you will try to do it like it happens right now.
So the question is, let's say if the circuit is open and Redis fails at the same time, and service comes up, will this circuit be able to close again?
Circuit, if Redis goes down, see, just like what we are doing here.
So the sequence of event is that the circuit is in open state, the Redis cluster fails, and service comes up. So will that circuit be closed again?
Yes, because whenever we are, there's a request coming, we are first checking the state of we are checking the state of the circuit from the Redis. If we are not getting any state, the request will.
So it will be considered as closed.
Yeah.
If we are not getting any state from the cache, then it will be considered as closed. Then it is fine.
Then
And there would be, we can do many things on top of it. You can, as you were mentioning, we can try and build a retry mechanism for our requests that are coming in open state, and we can extend its use case for that.
one more question: how much circuit breaker is helpful in the async architecture? Since we are going towards Kafka-driven architecture, right? Event-driven architecture, so how it will be helpful there?
So the major agenda of having a circuit breaker is to my downstream service to stop the connection, making the upstream service to making stop the connection. It could be used for the database as well. Say one of the services making a latent queries to the database, so it will just break those queries, and the queries which was written fine will be all available to serve. Right? So it's nothing related to the after all this. These no service options very but we can
Through Kafka कर रहे हैं, through broker कर रहे हैं. So how the circuit breaker will be rolled?
So,
Broker कर रहे हैं.
yes.
So, basically changing the ledger library, right, to get the support of CG Redis library. So, what advantages that CG Redis provide over Ledger's Redis?
So, Ledger allows us to use any kind of cache, like say Redis or anything else. But see, since we are using here, we are providing support for CG Redis because in CG Redis we have written certain things like whenever a key is created, we include the service name in the starting, we include the environment name. Those all functionalities are already available in CG Redis. That's why we extended support for CG Redis. If we use any other in general cache, we will be creating keys. But say for example, there is a request which FO service is also calling, and say some other service, say calling service is also making same request. So when the service name is appended in the starting as offered by CG Redis, you will be able to differentiate because circuit breaker is usually implemented by the calling service. Say in FO service we are calling recovery service. So FO service will put a circuit breaker on top where recovery service is getting called.
So, you are saying that because of some features which we have in Redis library, like figuring also attend,
Yeah.
where the raw library can detect that the function is call and reconnect to the Redis cluster, right? And Azure does not support.
So Leisure has, Leisure just asks you to give it one circuit state storage, which can be any kind of Redis cache or any other cache, on which it can store the states of the circuit. It can store the counters, everything.
It has given an interface, right? Any caching library which respect that interface will
Yes,
work with
yes,
Azure, right?
yes.
So we will be changing we will be adding that interface to Redis library, or we will be modifying Azure to work with CG.
In Leisure, we have written an adapter, a small adapter, to function with the CG Redis library. In CG Redis library, there are some functions like CG Redis library, I guess, is written on top of AIO Redis, but like there are functions in AIO Redis like expire, like increase, which are not written in CG Redis. So we have to also extend support in CG Redis for those functions.
So basically, what he will let the data he is writing an adapter in the Azure to accept the interfaces from the CD Redis. Also, there is something required in the Azure end, which is available in our down library, which is under which we have written a wrapper. So we have to extend the CD library as well and have changed the Azure.
I can show you from the code level as well what we are doing here. Hello. So here you see there are various adapters available for different caching libraries, say AIO cache. So this is the interface which we must be talking about. Like any circuit storage library that we use must be respecting this following interface, must be having these functions. But there are functions like expire, which CG Redis does not support it. There is function like increase, which is present in AIO Redis, but CG Redis does not support. So we should also extend that functionality in CG Redis to give it full support. And what we have done here is we have also written a small adapter for CG Redis library. Like the base of Azure wants add function, which is not available in CG Redis or AIO Redis. So we have modified it to support functionality for add. So that's what we have done here. I can now go to the code part and show you guys how we are doing it. Okay, so here is a small API that I have written. So what this API is doing is, this API is simply calling this function, which is getting some data from database and returning it. Now on this database, I have included circuit breaker. We can include circuit breaker as a decorator simply. Let's see some of the things. So in circuit breaker there is a rule which is offered by Azure library. What we do here is this rule allows you to define what would be the minimum accepted request after which you can start counting failures. What is the max failures percentage, which is our failure threshold, after which you will be tripping the circuit open. Now there is a failure exception. This key will allow you what kind of exception should be raised when the circuit is open. When the circuit is open and any request comes, open circuit exception will be raised. Now you can write any custom exception here. Then there is cache exception. So cache exception is which currently was. In cache exception we can define the various exception classes for which we want to raise a failure and we want to count in failures. If you leave it empty, any exception that is raised will be counted as a failure. Similarly, we have added one cache status functionality here. This is added on top of failure, which was not present initially. Here we can use status codes for failures, for counting failures. Like say for example, if any underlying service or API returned 400 or 500 status code, then that will also be counted as failure. You can define that. And finally, there is success threshold. In success threshold, you can define like whenever the circuit is in half open state, how much success request should be there to trip it back to closed state. Okay, so let's see it like. So this is a local British. So as of now, there are no keys present here. So let's make a request now. So it's success 200. Let's see what is happening in the back. So there are two keys created here. First key, this key will be keeping the count of total requests that are coming. So one request, and this failures key would be keeping a track of how many failures are getting created. So there are 0 failures as of now, and there is one number of requests that is occurred. So let's it's now 4. Now, say for example, to throw an exception, I'll just change a column name here which does not exist. Let's see now what happens. Okay, so the API is failed. There is an error that has occurred, there is an exception that has been raised. Just look at this log, what it is saying. It is saying that minimum accepted requests are 2, maximum failures which we define in the starting. Total requests are 5, and there is one number of failure that has occurred. Now the circuit will not trip open unless the failure threshold has been reached, which we have set 50% here. So this is 50%. Let's keep hitting more now. Let me tell you, this response is coming from the API only. Circuit breaker is not doing anything till now. Now this response has occurred. Now this is the open circuit exception which we wrote, and let's look at the states now. So let's check out. See, this new key has been created. Let's check out the state. The state is open. Now this key which you are seeing here, this key would be when this key is present, its expiry would be used as a counter here. Till this key is present, the circuit is open. When this key gets expired, you can assume that the open circuit timer has closed. As of now, I've set the expiry to 1 hour. So you can safely assume that till 1 hour, no request will be allowed to the underlying service, and the circuit will remain open. No matter how many times you hit this, no matter what will you do in the original service, say even if I change it back to the right one. The circuit is open, no request is thrown. In the logs also, if you see above, you will find a log that the circuit is open. See, whenever the circuit was open, a log was also recorded, signifying that the circuit is now open for this request. Now, I delete this key so that when this key is not present, we say the timer is stopped running. So I just deleted key for now. Okay, so when this key is removed, as I said, when the timer stopped running and the request came, the circuit will then trip it to half open state. In half open state, the request will be allowed to flow. Okay, so we are getting the response here. Let's see the states now. What can the keys? You see, there are no keys added here. Let's take the state. The state is half open. This is our success counter, which will now keep a count of consecutive successes that has come. This is 1 year, and this again denotes the total request. Now, for the success threshold, I said here 5 requests. Okay, till the time we give 5 consecutive successes, the circuit will remain in half open state. If any request in between goes failed, then the circuit will turn back to open state. Let's make a couple of requests more. The successes are 3. Let's see if the exception occurred again, then what happens. Let's look at here carefully. Remember, the circuit was in half open state and it was allowing request till now. I hit a request, the request failed, and see what happened again. Let's check its state. The circuit has stepped back to open state. It won't, the timer will restart and it won't allow any request to flow again till the time the timer is running. Yes.
Open state or pull request again to pull in a parameter. But it is not because the DB response is there. It is because of some error code exception. Some line error कोई डेटा नहीं है जिसकी वजह से फाइल आ गया. तो उस केस में सर्किट ओपन होना चाहिए.
It depends on where you have placed your circuit breaker. Like here, I have placed my circuit breaker just on this function. Okay, so if anything goes wrong with this function, then only it will be counted as a failure and it will be used to opening or closing the circuit. Any other failure apart from this will not be counted. So it depends on how you place the circuit breaker or where you place the circuit breaker. Remember that circuit breaker is mainly used when we are calling any other service or any other resource. So say if you are calling recovery service here or any other service, recovery service here, and on top of that you place circuit breaker, then it will work on that. Yeah. Yes.
So you have taken the real right of the key.
Yes.
Real time or when we do in production, like how do you decide that this is the time it should be that such a service should be 1 hour, right? Let's say typically it's 1 hour and the service was just down for 1 or 2 minutes, which caused the circuit to open. But now for next 59 minutes, the request will be not served properly. Basically, the same response will be returned back.
Yes.
The failure response. How do you take the time? Like, what will be the best time for us?
So I guess here, what we can do is as we need to understand, we need to decide, say what kind of failures are you expecting from this underlying service or function to happen. Say for example, if it was a TV choking, now you need to decide how much time it might take when a TV gets choked to recover. So it's a little subjective question because you cannot put a very specific number. It depends on, because what is this timer? This timer is basically say giving the underlying service a time to recover. So it depends on that how much time you are expecting, under which this service will be recovered. That time you need to place.
But whatever time you choose, that will easily linear way, right? Every time. Let's say you choose 5 minutes, right? Let's say you have seen everything that 5 minutes will be yes, the DD will be up, no choking there. Now again the same scenario will happen. First window starts, in the first minute the circuit opens, then for the next 4 minutes no requests are being served. Next after that, when the 5-minute window is over, in the next again window, for the first few requests, it again shows, right? Then for next one, so when you take this total 10 minutes of time, you have wasted 80 minutes which could have been served, right? So shouldn't we use some kind of strategy like exponential increment of the timer or something like that, where we take a very next time, let's say 10 seconds, and we check that the circuit is okay, then we keep increasing that timer over specific time.
just a suggestion to consider.
इसमें एक और पॉइंट है, मेनली ना सर्किट ब्रेकर टू वर्क इट प्रॉपर्ली, जो हमारी अंडरलाइन सर्विस है जिसकी कॉल पे हम सर्किट ब्रेकर लगा रहे हैं, दे शुड आल्सो हैव हेल्थ एंड पॉइंट. सो जब हम हाफ ओपन स्टेट में होंगे उस टाइम पे वी कैन कॉल दैट अंडरलाइन सर्विस whether it's healthy or not, then we can take a collective decision instead of waiting for the timer. तो ये इसका और मतलब स्टेप फॉरवर्ड है, बट फॉर दैट और अंडरलाइन सर्विस हैज टू इम्प्लीमेंट दैट हेल्थ एंड पॉइंट, सो दैट जब हम हाफ ओपन स्टेट में होंगे वी विल नॉट ओनली rely on the counter, we will get the health end point. If it is okay, तभी हम क्लोज करेंगे. So that is the phase 2 of this implementation.
मतलब it can be like can keep on pinging after some time. Like they can be a polling strategy as well. Like as Khushbu mentioned to for the health check of the underlying service. Like for the underlying service, yeah.
How will that be functional failures? For example, you are calling record, right? Everything is working fine except for that one API that you are required.
So
In that case, you are breaking circuit because your the API that you require is not working. That should be breaking service, but everything else is working fine.
So this health check what Khushbu just talked about is not for the entire service. It's for the specific APIs. There are health checks for the APIs as well.
For every API, you are expecting a
No,
health
no,
check.
no.
Yeah.
So basically, health check usually works is you will have a single health check for process service the record, right? In that health check API, you can always pass a the API unit, which what it does is it actually executes a unit test case to check whether this API will be able to work as expected, and it will actually execute. You should have a unit test case for an API there in the service to support these level of health checks.
Some sort of mock API.
Some sort of internal mock API within that service. So within that service, it will execute that, and you need to pass an API name and a health check.
But that's true. Like the underlying API has to give a mock health using which we can poll and check it.
That's a standard practice that everybody does. And that is how the circuit usually get closed again.
Second question I had regarding how we are choosing to link the circuit. Because right now what I understand is the strategy is only about counts.
Sorry?
Strategy is about counts.
Yeah.
States are identified using that. I don't see a flavor of time there, and that I see as a problem. Why at least?
Time is there. Basically, the expiry of these keys will give you the time frame. See, the circuit, like initially when you place the request, the total count that you are maintaining in the key has an expiry, and the same expiry is set to the failure count key as well. Sorry.
Expiry.
So the default expiry is been defined in the class, but you can always pass it. Make moves. So here you can see this is the instructor. Here what we are doing is this bala. This is the failure timeout that you are setting here. You can pass it whenever you are using the decorator. You can pass the timeout for which you want to set.
Let's say from morning till now, there were thousands of requests and everyone was successfully passed.
We also basically the timeout there. So whenever you are storing the starter counter, right? This is a time bound activity. So like after an hour, it will get refreshed. The counting will get refreshed. You have the timeout as well, no?
Yeah, this is the timeout will be set. Like the failure timeout and the circuit timeout, you can set it. You can set for the other keys as well, like the success keys that you are counting, and these three other keys: failure count, success count, and the total request count. It will then be in a time frame, like how many requests are failing in this particular time period. After that, when the time has expired, the new count will start. So there will be always be a time frame. How many requests you want to see failure in a particular, say, if the 50% requests that you have defined. So 50% requests have failed in 1 hour, not the 50% requests failed overall.
It's a running window or hard window?
Sorry?
It's a running window of the 1 hour of hard.
As of now, that's hard. See, it's not a slide running window. Like from It's from 130 to 230, 1 to 2
Ready, it should be done.
What?
Explicitly, since see to pass assembly, all these things are stored in Redis keys only. So if you want to do it, you can go and change it in the Redis directly.
Delete that key.
Yeah.
But again, Suresh ka point is correct. It should be sliding window. Because right now is that when I set it at 130 and 230 it will expire. Say my failure started at 230. My numbers will get, but it can take it.
Yeah, we can take it as a free. Any other question?
Yeah, except support the middleware or just only decorators.
Sorry.
It has a middleware or just only decorators.
So you can use it as a decorator. You can use it with the build functionality that Python offers. So both ways you can use it.
It is like service level, you can also go down. Maybe the service go down. Or maybe some of the APIs go down inside the service. Or you put that.
I'm not able to hear you.
Yeah, entire service can go down or one of the APIs go down. Only under these two parts.
So, say for example, if you call any API for say user service, if the entire service is down, then also that API will not return any response. If that particular API is down, then also it will not return any response. So both is one.
It is at the API level as of now. It is not at the service level. So but this has to be implemented or the decorator has to be defined on every API for which you want to maintain the service.
You are not basically looking for the entire service, you are basically looking for a part of the service.
It is just a decorator.
Maybe some concept you can add for the middleware. Maybe the entire service go down. So you can also checking for each and every API.
Basically, Suresh is talking about some other implementation which is having a middleware in place which can actually apply the circuit breaking on all the APIs of the upstream.
मतलब अगर पूरी API down, service down.
उससे आपका एफर्ट बचता है टू इम्प्लीमेंट इट ऑन एवरी एपीआई इट विल बी लाइक डायरेक्टली
अगर एक सर्विस में 10 एंडपॉइंट है, सर्विस डाउन है, तो आप पूरे 10 एंडपॉइंट अलग-अलग चेक करके मुझे एक बार में पूरा कर देना।
Yes, we can think more on it.
haven't thought of that direction so that is good idea.
And how we are planning to put it at the DB level? That's the DB as a resource.
Which the example which I just showed was put on DB only. It basically goes for the exceptions that are raised. Like here the DB call is only happening, so it will catch the exceptions whatever you define here. Okay, if this is empty, any exception raised would be handled as an error only. So you can place it basically on any underlying functions, considering these two cases are there. Like either you can catch any exception for any underlying function, or you can use a status code. So on DB level, you can handle it using any exceptions that are.
So currently you are assuming that my DB library will pass the exception to the
Yeah, exceptions must be raised, or you can handle any exception and raise it.
Does it going to help and the consumer?
Sorry,
Consumer side?
on the consumer side.
Reading the data from the Kafka as a real.
You can use the same thing but as of now I don't think it clears and
We have not tried it as of now, but I guess it can. So because it's simply a decorator, you can put it on top of anything and it will catch exceptions.
just stop reading anyways consumer needy बनाना अगर से DP डाउन तो कंज्यूमर needy बनाना या फिर कुछ भी डाउन